I'm going to do roprop, a challenge from CTF room. It was hosted at that platform in BIC Wintercon CTF. I was the one who blooded this challenge, and this is how I approached this challenge. So we are provided with the libc and then the binary. We want to use this libc, so basically you need to like hit enter into this next command. So basically we can verify that using this command, and we can see that we are now using the libc from our system. We can do dynamic analysis, and we are seeing that we are being asked for an agent name, and we can give it something, and we are given back an address. We don't know which address that confirms with, but we'll check at it using static analysis using GEDRA. We are told enter your agent again, so I'll just give it a random name, and we are told that an imposter. So basically what imposter means is that you are trying to be someone else or something of sort. So I'll just jump into GEDRA, and this is just a cleaned up version of the disassembly of this thing. Not the disassembly, but the decompilation of that thing. We ask for the name, of course, and then it's reading 16 bytes, but then we are using printf without a string formatter. So basically if we enter a malicious input, it will like print out the values that we want. Not we can control basically the output of that printf. From there we are given the address of printf. That is really nice. And then there is the canary check here. So canary is the stack cookies, so basically they prevent you from overflowing the buffer or something of sort. It's more of a mitigation. You can just refer to it as WAF or whatever. Having known that, we can like just jump ahead to creating a pawn script. So I'll just call up my pawn script from somewhere. So the way I'll do that is the normal way. So we have our script there, and then I'll just update this, and since we are not using SSH, I'm just going to delete this, and now we have something that can work. From there, we saw that we are receiving something, so I'm just going to receive it there, and we can see that we are using the run path current directory, and that is really good. So we enter the name, of course, and then we are told welcome our name. So basically the reason why the first line was not printed, it's because we received it and never printed it out. We will print it out in the course of the next coding of the script, but for now let's just use it as it is. We are getting the printf address, and then we are told to enter our agent, so I'll just enter the same name. So we are told it's an imposter, and we get an end of file, so that's really nice. So I'm just going to use log.info here. So this where we saw that we can like control the printf, since it doesn't use a string formatter. So basically we can enter some malicious input, but for now I'll just send my name. So from there we are receiving the address, so that is the leak, and I'll just print it out here also, and then that's okay. So let's try to test our script, and we can see that everything is in line. We are sending the name, of course, and then we get the address here. That is the address, and then we are switching to interactive mode. So to test our theory on the string formatter, we can enter something like this, and we see that we are outputting an address. So basically this calls in for GDB, so that we can do some dynamic analysis and to make sure that we get the address that we want. So from our theory here, we want an address that is the canary. So basically, so that we can overflow this peacefully without the canary mitigation hitting us, coming to us very ugly. So basically, to avoid the canary being ugly to us, we'll just leak it and give it the canary that it wants. Then we'll overflow the other parts with our data. Okay, so that is what you are going to look at right now. So I'm just going to open GDB in quiet mode, and from there we need to set a breakpoint somewhere, or maybe we can just hit start, and then we are in main, so we can disassemble something like that, and then from there we know that we are just going to hit around three instructions, so that we can like arrive at where the canary is being produced. So let's hit next, and then let's disassemble this. You can see that now RAX is being moved to RBP minus hex 8, and now this is the canary. So basically the canary is being moved to the RAX. So we can examine the canary from here, and you can see that this is the canary. So the next thing we need to do is just hit continue, and then we want to get some values, maybe from maybe 26 something of sort. So the 22nd number, we get it's nil, and that's okay, but we can break there and then try to like get these addresses from the RAX or the RSP. So we need like 20 addresses from the RSP, and basically since this is a 64-bit binary, we can just hit something like that, just trying to identify where our we're just trying to identify where our canary is. So it is ending with 900, and we're just going to get that. So we see that 900 is here, so that is our canary. So basically maybe we leaked something around here, because we got that was nil or something around here. So I'm guessing it's around here. So we got nil. So basically what I'm going to do is leak an address at around the 30th position or the 31st position. We get that the canary right now is ending with 800, and now we can hit continue and leak the 30th position address. So we get that also is nil. Interesting. That is like really interesting. We're just going to start it again. Then we can check this, and you can see that now it's ending with this value. Not sure. Let's just continue. Yeah, it's this one. So basically let's hit continue, and we will try to leak like around 3 addresses right now. So this will be like that. So consecutively we try to leak this, and one of them was our canary. So that is really nice. So basically we know that the 31st position argument will be our canary, not the argument, but basically the addressing the 31st position of the RSP, that is the stack, will be our canary. So that is really nice. I'm just going to copy this payload and then paste it in our script. We're just going to send it, and for the data that we'll be receiving, basically we know that we will get 2 addresses. So I'm just going to import the regex. It will make this easier. So this is supposed to be assigned to, not the other way around. Yeah, and we get that we are getting the canary over here, and we are getting the printf address over here. So the next thing we are going to try to do is use regex to extract these addresses from this piece of line, and we'll be good to go from there. So basically having these 2 now, we can printf the canary, and we can print out the printf address. Yeah, and you can see that the printf address is that one and the canary is that one. So hitting next input, you are told that we are an imposter. So basically having the printf address, the next thing I'm just thinking is getting the libc base, and that's the next thing you're going to do. So just for readability, I'm just going to label these parts as maybe here we are going to getting the addresses. So remember when we initialized our binary using the elf thing, it basically took also the libc of it. So basically we can try to get the libc from there. So we're just going to say libc will be equal to our elf.libc, and then the libc.address. So this will automatically like figure out the other addresses if we do it this way. So our printf, then you minus the libc.symbol.printf. So that is basically the offset of the printf function in libc, and then we can like try to print it out using the log.info. I'm not sure if this will be maybe we want it to be in hex, I guess. And okay, so we cannot do that. So basically we need the printf in integer, I guess. Yeah, and you can see that we now have the libc base there and we have everything aligned. So to confirm this, we are just going to use gdb. So we can set the disassembly to Intel. And so basically what I'm just going to do is hit continue and then break and then do the info. So basically before we do that, we need something like this. So we need to do info proc mappings. Yeah, and we can see that the libc is around here, and that is the address that we have. So that is 767F6875 and then 6 and the rest are zeros. So we have successfully leaked the libc address and all that. So the next thing you're going to try to do is now look at the input that you're sending here. So here is your gift. So we have the hide function here. In hide function, we are seeing that it's using the enter your agent thing. So it's just printing out that line and it's using gets to get the input. And then the buffer is 136. So basically that is the buffer length. So using gets, of course, we will overflow this one. And 136 is basically the offset. We just looking at it from the disassembly thing. 136 is basically the offset, since this function does not have a lot of things. So we are just going to send this data, then we will overflow the, so the canary will remain the same between the two functions. And the next thing we are going to try to do is send data that will overflow this thing. So at first we are just going to send normal data. So I'll comment out this one. From here we need to get the offset. So we are trying to get the offset to canary. So I'll just do a p.receive, I think. Not sure. How was this binary like? Taking this thing. Yeah. So enter your agent. We need one receive line, I guess. And then can we do something like, okay, just going to print it out like that. And since it's not coming back, means that we didn't need that one. So I'm just going to make a payload here and say we need something like a cyclic of basically we know the buffer it's 136. I'm just going to send some a's multiplied by 136, then add the canary. So this is supposed to be the canary, I guess. So the way this thing is, so we need to do a p64. So pack this thing like that, and then maybe we need these ones to be like 2 times or 3, I guess, and then do a payload cyclic of like 10, and then from there we need something like p.sendLine. Yeah, p.sendLine, we need the payload, not the cyclic thing. From there I think this is alright, but we need GDB, of course, to check of course to check the registers and all that. So we are there and we can hit like next, I think. So I'm just going to disassemble the hide function, and we are going to break at hide plus 175. So that stopped because the list is out of range, so we need to do that quick. So we are just going to break at hide plus 175, continue. So then you're just going to set the disassembly to Intel, then set the pagination to off, and then we can examine the data in the RSP, and we get its hex 85A6300. You know, what I'm guessing is that this is our canary. That is what I'm guessing. So let's see. Yeah, this is our canary. So basically we overflowed the return address with our canary. Let's see, if we hit enter, this address will be the one that will be going to the RIP. Yeah, and you can see that is interesting. That is really interesting. So I'm just going to check the register here, and let's see. Here comes the RIP, and I'm really not sure where that address is, but let's see. Yeah, sure, I think it's this address in backwards, I guess. Not sure, but anyway, I think our canary came there. So what I'm going to do is reduce, we are multiplied by 3, we are just going to give it like once, I guess. So we were breaking at hide plus 175, then continue. So examining the RSP, we can see that here is our pattern and it's not enough, so basically you need to give it more. So I'm just going to send a pattern of maybe 20. Yeah, and we get this one. So what I'm going to do is do something like cyclic and then tag L, something like that, and we get it's 8, so the offset is 8. So let's come back here and say now the offset equals to 8, and then instead of giving it this one, we're just going to say offset. That means nothing basically. And the next thing we want to do is now send some rop here. So I'll just make a section here for our simple rop chain, and the first thing I want to try to get is the return, I think. So I'll use roper for that. Yeah, I'll use roper for that, and maybe I'll just do something like this. So we can search for in the depth of 1 for something like return, I think, and we get one gadget here. So the reason I'm doing this is because the PI is disabled and all that. No, actually the reason I'm doing that is because this is the offset and we have the libc base. Yeah, so I'm just going to name this as a return here. So just cleaning it up here, and then we need something like the pop RDI, and we get it here, and we are cleaning it up here, and we need the binsh string. So what this will do is that it will call the system, it will be the argument to the system call. So the way I want to find it is using next and then libc.search, then you're just going to search for that string in the binary, something like that, and then we need the system, of course. The way I'll find this is just using the libc.symbols.system. Now we can build the rope chain. So of course remember to pack the bytes, and then we'll call the pop RDI. So what this will do is pop whatever will be on top of the stack and then store it in the RDI register. So when that is being done, of course you want it to find the binsh on top of the stack, and then you can try sending now the system, and then basically we'll just send the payload plus equals to the rope. So if everything was done like correctly, this is supposed to give us a shell. I'm just going to do something like that, close up this tab, and then we can now head straight to GDB, and we get that addresses list is out of range. So let's see, where did we mess up? Actually I'll just do something like retab. I think that does it all. Not sure. Retab, I guess, and then something like that. Yeah, sure, maybe that works. This wasn't found, so okay, sure. So you need this to be something like bytes, I guess. So that's how Python likes it. Yeah, and you can see that there's a fork. So the way Linux works is that if you want to launch a new process, it basically comes as a child process of the parent process. So if in a process, it will be a child process of another process. Like all processes are child process of the system MD. Then just happen like that, like, yeah, something of sort. And you can see that the child process now is the bin.sh, and we can do list, and then we can like remove core, I think, can check the ID and all that. So this was the binary. So the way you would have done it like remotely, because that's where I think most of my friends are stuck, is that you need to comment out the GDB thing, and then if I think this was some random address, which was, let's just give it 21.0.1. so the way you are to do that, so it will try to connect to this address. So the way you are going to do that is that you needed to do some, I think, 2 times. p.receive was supposed to be 2 times on the remote end. So you're supposed to do something like this, because this how the remote server, I think, liked it. So yeah, you needed to do something like that. So I'll just comment it out for now, because you're not doing it remotely. I saw the server is like off, I think. So that was the binary. See you next time.